So after I got this car pretty much back in shape, I was driving out one day. The power steering failed while I was in a sharp right turn. It didn't just stop working, it actually jarred the wheel, torqued the wheel to the right, and put me into a curb, causing an accident. Jumped the curb, injured my spine, and that started a whole new chapter in the Ford saga. So I went on to do some more research, including talking to Ford quite a bit. Ford, turns out they had recalled a number of model years starting in 2011 for power steering failures. Now this vehicle has a TRW EPAS system. It's the electric power assist. I believe it was originally introduced in 2008. But this was the first Ford Flex 2010 to be equipped with the electric steering system. Now these steering systems are advertised to be fuel saving. They don't have any fluids involved with them, and they're supposed to be able to be programmable to allow you to give you much better road control, all kind of performance factors. But in fact, it's another example of new technology. In the case of many Ford owners, pretty much a nightmare. So after the power steering failure, vehicle was taken to a Ford dealership. It had an EPAS internal electronics failure. So something had completely failed inside the steering gear electronics, and that was the reason the vehicle no longer had power steering. Now, this is the exact same symptoms and the exact same equipment as used on all of the recalled Ford models 2011 and above, just a few months ago. But this is a 2010, and Ford decided that they were not going to fix the identical problem and identical equipment in this vehicle. So I went into a long battle with Ford again. Over months, Ford requested all kinds of crazy documentation to delay. Finally gave up on them completely and had the EPAS system removed from the vehicle for evaluation. Now, if you're not familiar with an EPAS system, this is what I'm talking about. This is the TRW electric power steering gear. And as I've mentioned, this replaces the hydraulic system in older cars. This EPAS system is quite complex. It has a lot of internal components, electronics and mechanics. It's comprised basically of a brushless DC motor, which drives a belt drive, and there's a worm screw in here which drives the rack back and forth to actually steer the vehicle. Now this is a completely self-contained unit. It basically has a power connector and a CAN bus communication connector and an encoder interface, which comes over here. This is your steering encoder, and as you turn the wheel, this encoder basically communicates the position to the internal motor controller, which then allows the motor to servo the steering to the appropriate position. Now, this is the electronics enclosure, and internal to here, on this side, you basically have a signal conditioning board, power conditioning, and communications conditioning, and interface to these connectors. And then you have, in this vicinity, a fairly sophisticated motor controller and brushless DC drive, which pretty much comprises the electronics. Now this thing is absolutely packed with components. It's all miniaturized, surface mount, non-serviceable, and it's quite an implementation. It's very complex, which also leads to the fact that this unit is very expensive. Whereas a normal vehicle, you could repurchase a steering gear for, $200 or so. This steering gear actually costs about $1,600. Yeah, $1,600 for a steering gear. Now, since Ford offered no indication of what was actually occurring with these units, they've been very secretive about it. I did a lot of research myself, and I dug up the documents that were the communications between Ford and the NHTSA before the recall. And I found a lot of documentation that the NHTSA had actually requested from Ford a full evaluation of the problems they found on the recalled units. And Ford basically came up with a number of different manufacturing flaws, they called them. Two of them were basically conformal coating would migrate during the assembly process and basically coat a number of connectors and prevent communication with the encoder. In addition to that, they also cited misaligned connectors, which could possibly result in also loss of encoder signal and failure of the system. Now, I was an electrical engineer for over 30 years, and my job was to design equipment like this, electronics for equipment like this, in the robotics industry. So I have a lot of experience with electronic implementations, conformal coatings, miniaturization, surface mount, all that stuff. So I found Ford's explanation of the problem quite suspicious from the start, because in today's surface mount world, you just don't see these kinds of manufacturing issues, especially in an implementation like this. And I'm sorry I can't show it to you. I had this apart when the system first failed and did a full evaluation on it, and I'll give you some information as to those results in a minute. But I was suspicious of Ford and the explanation they provided to the NHTSA as to why these units were failing, and that led me to start my own investigation to determine what was going on, so at least I could understand what Ford was not talking about. So I pulled the unit apart and got down to the electronics behind this plate here, and I immediately discovered that the unit is really not serviceable. And really it's not serviceable for only one reason. Ford provided some heavy-duty contacts from the power interface board and the motor controller, and they basically spot welded them so that you really couldn't remove anything without hurting the power connectors that interface the two systems together. So I was able to get around that because I have some experience in that field. So I detached the unit and was able to completely disassemble it. Now, the first thing I did was I referenced the NHTSA/Ford document describing the problems that Ford had reported to the NHTSA. And I went through them one by one. And on each case, Ford had identified specific areas on the circuit boards that were affected. Now, I looked over every single one of the points, and I found absolutely no evidence whatsoever of any conformal coating, connector misalignment, and such that Ford had talked about. It was just non-existent. And after looking at the implementation, I was convinced that that was something Ford had fabricated, pretty much to tell the NHTSA an easy fix to get around the real problem. So what I did find, first of all, evidence that there were heating issues with the unit. TRW during the manufacturing included some capacitors down here in the signal conditioning board, rather large filter capacitors, and they gooped it up with just copious amounts of thermal compound, white thermal compound, far too thick to serve any purpose because it just dries out over time and it loses contact and integrity. And I found this flaking white grease pretty much non-effective under this plate here. Originally they sunk it to the internal housing, but it had dried out completely and was not serving any purpose. But the capacitor really wasn't damaged, so I figured that's really doesn't really look much like an issue. However, I looked further and I went right to the motor driver. Now, these brushless DC motors use something called an H-bridge driver. and it can be made from bipolar transistors or MOSFETs, and I don't know which one they use in there. However, I was able to locate the motor leads, and I did some ohm measurements, some resistive measurements, to determine if the motor drivers were actually faulty. And I found that 2 of the MOSFET outputs were shorted, indicating burned or blown out transistors or MOSFETs. So it's clear to me that the reason this unit failed is because the motor driver failed. And MOSFETs fail for a number of reasons, but in an instance like this, there's really not too many causes, and the primary suspect is thermal overheating. So that, coupled with the fact that I found basically boiled off white thermal compound internal to the unit, really made me suspicious that really what was going on here was a thermal issue that Ford has obviously encountered, and I'll go over that in a minute. And they've basically implemented a lot of different things internal to the engine compartment to try to handle this issue. And these are clearly afterthoughts, and they seem to have been ineffectual in actually protecting this unit from the amount of heat under the engine compartment. Now, one of the first things you notice about this implementation of 3.5 liter is that it's very tight, even in a vehicle as large as the Flex. There's no space at all in this room. I mean, you basically can't put your hand down anywhere through this engine compartment without encountering something. And Ford has crammed 2 turbochargers and 2 catalytic converters into this implementation very tightly. Now, you can't see them here, but there's a rear bank and there's a front bank turbocharger. The one back here is the one that I feel is problematic, because basically it's a turbocharger that's located right at the exit point of the exhaust and right above the power steering gear electronics. And the turbocharger pipe exits, the exhaust pipe exits the turbocharger and immediately goes into a catalytic converter within inches. And what I discovered was that Ford went through extensive measures to add heat shielding to this implementation. Now, the EPAS power steering gear and the catalytic converter and turbocharger is basically mounted within 3 inches of one another with a heat shield between them. And that, I feel, is highly problematic. Even with the heat shield is just going to heat up to a high temperature, and you're going to have that EPAS electronics enclosure exposed to very high heat. Now, catalytic converters can operate as high as 1200 degrees Fahrenheit under good load. Typically, they run between 500 and 800 degrees Fahrenheit. The turbocharger, this is a water-cooled turbocharger, so it runs cooler than most, but still, you have exhaust gases which are close to 1700 degrees Fahrenheit going through the exhaust system. So even in a water-cooled system, you're going to have quite a bit of heat radiated from the turbocharger. Now, if that wasn't enough, the exhaust itself, once it comes out of the catalytic converter, continues right under the EPAS electric power steering electronics enclosure. So you've got really 3 very large heat sources in extremely close proximity to the steering gear in the back here. And that is what I suspected was really the culprit behind the steering gear failures, at least in this Flex and the 3.5 liters. So once you start to look for heat issues, it becomes apparent that Ford was fully aware of a heat problem because they implemented a number of systems to handle heat. One of them is this large air dam under the vehicle. Now, this specifically channels air right exactly to the area I just mentioned between the turbocharger, catalytic converter, and EPAS electronics enclosure. There's also a second air inlet which channels air up to the other turbocharger. When you see this kind of implementation, it's pretty clear that Ford was working on a heat issue. I was hoping to show you exactly how close Ford mounted the EPAS steering enclosure to the catalytic converter, exhaust pipe, and turbo. But it's pretty difficult to see under here for now, so you have to pretty much take my word for it. You could do your own research, but I can point out, you can see the heat shield to the EPAS. They have a large aluminum heat shield over the EPAS system to try to protect it. And then right here you can actually see that's the catalytic converter, which is at, like I mentioned, 1200 degrees Fahrenheit. It's within maybe 3 inches at the closest, and at the furthest possibly 4 inches. So it's easy to speculate about a thermal issue. It's another thing to actually take measurements to determine if there's a problem or not. Clearly Ford has implemented quite a few systems here to try to handle a heat issue. We have the shielding, extensive shielding around the turbocharger, catalytic converter, and the EPAS steering housing. And so what I have here is a Fluke 80TK thermocouple module rigged to my Fluke 77 meter, and I'm reading this out in degrees C right now, 27.8 degrees C, which is somewhere in the 80 to 85 Fahrenheit range, I believe. And I've got this hooked to the EPAS electronics housing, right on the housing itself. And the engine has not been started. The car has been sitting overnight, and it's a pretty warm day today, so this is just pretty much ambient temperature. What I'm going to do is take the car out, run it pretty hard, get the engine nice and hot, come back, park, plug in the module again. I'm going to try to leave this thermocouple as it is because I don't want to get under there when it's hot. I'll plug in the module again, and we'll take a reading to actually see how hot the EPAS aluminum electronics enclosure is getting. Okay, I've run the vehicle pretty hard, about 30 miles, hard acceleration at times. I'm sure it's pretty hot at this point. There's a lot of heat coming off the engine here. I'm going to plug the thermocouple back in here and see what we get. Yeah, we're at 85, 82, 81, 82 degrees C. That's pretty hot. That's about over 180 degrees Fahrenheit. And I'm just touching the thermocouple on the side of the electronics enclosure for the EPAS steering gear. That is definitely a very high temperature to be running. I'm a little surprised at that. That clearly indicates that Ford is running this EPAS system at a very elevated temperature. I would expect when you turn the vehicle off that temperature probably even rises more because there's no airflow at all. Just as reference, industrial electronics runs maximum temperature about 85 degrees C. Is really the limit you should be pushing any industrial class electronics. Now mind you, this is reading 88.6 right now. So it's actually over the temperature, the normal operating temperature for industrial electronics. That means, junction temperatures for industrial class are around 150 degrees C or so, and operating temperature around 85. So that means that these components are getting extremely hot and they're degrading. This is clearly a problem. And I'm sure Ford knows about this. This is not something that's very ambiguous. All you need to do is do what I did, hook up a simple thermocouple to the electronics housing of the EPAS system, And you can see clearly that Ford has got an issue here. Now, they haven't talked about this at all. However, if you look at some other recalls, for instance the Mustang and another one I can't remember, the Mustang in particular was just recalled because it had extreme overheating under the engine compartment. So this is nothing new. You take a EcoBoost engine, put it in an implementation where everything's tight under the hood, very little airflow. This is what you get. There's a problem. Yeah, I've turned the engine off now just to see what happens, and it was sitting for a while at about 82. Now it's down to 77. So the temperature's coming down a little bit as the vehicle's been turned off. But still, that's an awful scary temperature for electronics to be running at. And mind you, keep in mind that I'm measuring the temperature of the external enclosure. This does not include what's happening inside the unit, which you have to expect temperatures to be even higher.